Cryptography, or code breaking as it is often known, is the science of disguising a message so that only the intended recipient can read it, and is believed to have existed in societies as early even as ancient Greece. Various forms of ciphers with which to encrypt messages have been developed over time, and until the 20th century they usually employed clever manipulation of words, letters or numbers. However, cryptology today is widely considered to be a primarily mathematical and computerized practice rather than linguistic. This is because factors such as the invention of the Enigma machine and the work at code-breaking institutions such as Bletchley Park, as well as great advancements in computer technology and security, have largely eliminated the need for written codes. Written cryptology can be divided into two branches: transposition and substitution. A code using transposition will take a message and rearrange the letters in some way, effectively creating an anagram. For example, a popular cipher using transposition is the rail fence cipher. Here we have a sentence which has been split letter by letter into two lines. If we were to take the bottom line and move it onto the end of the top line, we would have, to anybody who doesn't know the method, an apparently meaningless string of letters. Substitution is the other branch of cryptology and is more commonly used than transposition because it is more complex and therefore believed to be more secure. Substitution involves assigning each letter of the alphabet a figure, such as a number or another letter, therefore creating two alphabets, a plain alphabet and a corresponding cipher alphabet in which the code is written. The key to deciphering the message is discovering how the two alphabets are related. Deducing what kind of cipher is being used is known as working out the algorithm, or the key. Here we can see a message that has been encoded with a popular substitution cipher known as the Caesar shift. Writing this particular cipher involves taking the plain alphabet and shifting it a certain number of letters to the right or the left in order to get the corresponding cipher alphabet. This particular example involves shifting the plain alphabet 2 spaces to the right, so that C in the cipher alphabet is A in the plain alphabet. If a codebreaker was to work out that this is the algorithm being used, he could now decipher the original message. The most secure way of constructing a substitution cipher is to simply assign each letter in the plain alphabet a completely random number or letter, creating a cipher alphabet that only the author and the recipient of the message will know. This way, nobody will be able to break the cipher using a well-known algorithm such as Caesar shift or atbash, as the distribution of the characters in the cipher alphabet will follow no traceable pattern. As important as the ability to successfully create a cipher is the ability to break it, a skill that is known as cryptanalysis. Cryptography and cryptanalysis began to take real precedence as a science at approximately 750 AD, during the golden age of Islamic civilization. To run this prosperous civilization took a huge amount of organisation, and politicians and administrators alike had need for a means of making their communications secret to anyone but their true recipient. Combined with their great desire for knowledge, this allowed for a boom of secret messages and cryptanalysis. Islamic cryptanalysts developed the practice of frequency analysis in order to break substitution ciphers. This would involve identifying all of the symbols used in a cipher alphabet and using linguistic knowledge to deduce which letters they could correlate to in the plain alphabet. For example, in English, the most commonly used letter is E, followed by T and then A. So to perform frequency analysis on an English cipher, we would begin by identifying the most commonly used symbols and assuming that they are E, T and A. From there, the cryptanalyst would have to use logic and trial and error to deduce what the rest of the symbols could be. This would be a painstaking and time-consuming job, which would often involve having to restart the process several times with numerous guesses at what each symbol might be. This process was well suited to the analytical skills of a linguist, and it truly began the battle of wits between cryptologists and cryptanalysts. By the 15th century, cryptanalysis had started to become an important practice in Europe as well. Politicians, scholars, and other innovators during the Renaissance were starting to see the benefits of enciphering their communications, and in turn this meant that others were also starting to see the benefits of deciphering them. In Italy, for example, each state had established a cipher office, and each ambassador had an appointed cipher secretary. However, by this time cryptographers were starting to realise that their ciphers were far too susceptible to any unfriendly cryptanalysts familiar with frequency analysis, and were trying to find ways of making their ciphers more difficult to break. Until now, ciphers had been monoalphabetic, meaning that the plain alphabet had one corresponding cipher alphabet. So to make their messages harder to decipher, some cryptologists would use polyalphabetic ciphers, which used 2 or even 3 cipher alphabets, and with every letter of the message, they would alternate which alphabet was being used. Cryptologists would also employ techniques such as deliberately misspelling certain words in the message, and by scattering extra symbols that were meaningless throughout the text in order to confuse anyone trying to decipher the message. The introduction of code words was also intended to make ciphers more secure, but would often end up being a double-edged sword. Rather than replacing letters or numbers, code words would replace an entire word with another. Both the author and the receiver of the message would have a codebook, which held every code word and its corresponding meaning. The idea behind this was that if the message fell into the hands of an enemy cryptanalyst, there was no way that it could be decoded accurately without the codebook. However, if the codebook were to fall into the wrong hands, the entire game would be up, and it was for this reason that code words were never used as much as letter or number substitutions. A popular way of encrypting messages was to use a method called a nomenclator, which involved using a substitution cipher and a small number of code words to make the message doubly secure. A nomenclator cipher was famously used by Mary Queen of Scots during the Babington Plot in 1586. After being imprisoned for 18 years, Mary was in contact with Anthony Babington, a young Catholic plotting to assassinate the Protestant Queen Elizabeth I and put Mary on the throne of England. The two communicated through letters encrypted with a nomenclator cipher, which was secretly delivered to and fro by Gilbert Gifford, a young Catholic recently returned from Rome. However, Gifford was secretly a double agent, working for Sir Francis Walsingham, England's principal secretary and chief spymaster. All of Mary and Babington's letters were delivered via Walsingham's office, and his cipher secretary was able to break the nomenclator by using frequency analysis to crack the substitution cipher, and then deducing the small number of code words by the context of the rest of the message. Babington and the other conspirators were caught and executed in August that year, and Mary's execution took place in February 1587. Numerous cases like the Babington Plot exist throughout history, with the struggle between a cryptographer and a cryptanalyst deciding the outcome of a trial or battle, or influencing the decision of a politician or administrator. But in a new age of computer security, is this a dated science? And what role can a linguist play? This letter was written in 2011 by a gang member in prison to a friend on the outside. Although seemingly innocent at first glance, every fifth word of the message hides a secret instruction for a fellow gang member to be murdered. After cracking this code, the FBI have been quoted as saying that despite their state-of-the-art technology, the need to manually break pen and paper codes remains a valuable and necessary weapon. Today, forensic linguists such as Dr. John Olson are consulted by the police, the judiciary, and security services for help with deciphering written codes, such as this letter, which was given to Dr. Olson by the Greater Manchester Police and deciphered using the frequency analysis technique developed in the Islamic Empire. These modern-day examples show that the battle between code makers and code breakers is very much still ongoing in the criminal world, and that linguists are starting to be consulted as experts. With codes using clever patterns and manipulations of language, a forensic linguist with skills in textual analysis is the perfect modern cryptanalyst.